Hello, and welcome to this episode of Better Buildings for Humans, the podcast where we talk about human health, wellness, productivity, and joy as it is in regards to the built environment. And of course, we always have to talk about sustainability and energy management as well. Today, we have a special treat. We have Nick Bagatelos from NZE Glass. Nick is anybody who's in the glazing industry probably knows Nick or has at least heard of Nick's name. So it's a real treat to have him on the show today. Welcome, Nick. Thank you so much for being here.
Yeah, well, thanks for having me, Joe. If I get a chance to talk about glass, I'm gonna do it.
Well, fantastic.
It's been my passion for 35 years. So, thank you for having me.
No, it's my pleasure for sure. Let's start by having you tell us a little bit about your background, some of your past work, and the work you're doing now with NZE.
So I've been involved in the glass industry since 1987, but before that, I was involved because my father, for 27 years, worked for a glass company. So pretty much my diapers and my first bicycle were all bought because of my dad selling glass. We started our business in 1987. When I finished school, it was a non-union business in Sacramento doing storefronts and some stick walls. In the early 90s, I wanted to grow the business. I started Bagatelos Architectural Glass in about 97, and we went from doing storefronts to larger curtain walls and eventually moved towards doing campus facilities in Silicon Valley, built our own unitized curtain wall systems, built out a net zero energy manufacturing facility in the late 90s, early 2000s, excuse me. And then about 5 years ago, I was offered the opportunity to create a go-to-market for vacuum glass, and I'd been watching the technology at that point for about 10 years. And when I saw the fact that the technology is ready to come to fruition, I sold Bagatelos Architectural Glass, and I've been working to facilitate products that work with vacuum glass to create super energy efficiency in the built environment. And so I think that's kind of why we're talking is my desire to build energy efficient, transparent walls. So that's kind of what I'm dedicating the next, I don't know how many, 20 or 30 years of my career to.
Oh, that's amazing. So I thank you for that. And yes, that is one of the things that I definitely want to talk about today, and I want to talk about offline later too. But for now, let's talk about vacuum glass. Let's dive right in there. Why don't you start by explaining the fundamental technology behind vacuum glass?
Yeah. So vacuum glass is a thin representation of two lights of glass that the manufacturer develops a vacuum between those two. There's many different processes to do that. The first patents were filed 35 years ago. NSG has been producing a non-tempered vacuum glass for over 20 years in Japan. And you can buy the product here. Actually, this glass in the background is NSG's vacuum insulating glass. So the process is, instead of two pieces of glass, usually one with a low E and one with just a clear, and you do a spacer and silicone seals and create a normal double pane light of glass with an airspace between. Vacuum glass, you have a piece of low E, a piece of clear, you drill a hole in the piece of clear, you temper the glass, you place a ceramic or a metallic coating 3/8 around the perimeter, then you fuse those, then you place tiny pillars on the face of the glass, and then you fuse the glass to glass with that ceramic or the metallic. It can be done in a batch, in an oven. There's multiple different processes to do that. Once the two pieces of glass are fused together, you have a tiny spacer, literally the size of a human hair, between the two lights of glass. Then you pull a vacuum through that hole, you close that hole with a laser or a specific process, and at the end you have a vacuum between the two lights of glass. Now that vacuum is generally about 0.2 millimeters, like I said, the thickness of a human hair, and because there is a vacuum, the vacuum means there are no molecules. So conduction it moves through heating up the interior light. The airspace in between in a double pane light heats up, and then it becomes a conduit to transfer or conduct heat out of the building, right? Or heat into the building in the summer. So with vacuum glass, because we've removed every molecule, there is no actual matter to move the heat through. So you eliminate conduction except at the perimeter and at those tiny pillars. So the reason I'm interested in vacuum glass now, and I've been following it for 15 years, is that the manufacturing process is such that I believe it will hit price parity with double pane glass in the next 15 years. Now, am I right? I don't know. If you look at any product that's mass manufactured, the cost of goods drive it, and the cost of goods, if you have two pieces of glass and some tiny little pillars, it's a lot less expensive than two pieces of glass with a spacer and a desiccant and the silicones. So there is a path towards price parity, and I don't know when that will come in. And if you look at a technology like this, so we're talking, instead of 1 inch and R3 with a good triple silver low E, right, double pane, we're talking R20. You take the same makeup, except the glass is 3/16. So you've got less glass, you've got less space. So the product actually performs to R20 in a 3/8 inch unit versus R3 in a 1 inch unit. So that's kind of an overview of the product itself. And the fact that we can mass produce it now is going to drive the price point down. And because of that, there's 4 or 5 different manufacturers in the market. So there's factories being built in North America at this time. So I believe the technology is ready to take off. And if you think about the last big technology in glass, it was low E. And in 2000, there was 10 million square foot of low E sold. By 2014, it was 1.7 billion in North America and 2 billion in Europe. So I believe we're going to have the same sort of adoption curve with vacuum glass over the next 10 to 15 years.
That is absolutely amazing. So where is it now in terms of commercial viability, Nick?
So there's product, like I said, there's 5 different manufacturers that have product available in North America. The first factories are being built on the ground here. So I think there will probably be 10 to 15 million square foot capacity over the next 12 to 24 months. And then I think it will grow from there. So I think once people get this, I think the problem is going to be supply versus demand once people realize that the product is out there, is reliable, warrantable, and domestically produced.
So do you have specs now or actual installed projects? Or?
Yeah, there's product that is past all of the insulating glass requirements, all the tempered glass requirements. So the products are ready. I've got 3 projects that I'm working on right now that include new systems as well as the single pane replacement, which is sort of the first place to go after this, is old shitty windows that have single pane glass. That the solution that we all have today is displace a tenant, tear out the frame, build a new frame with double pane, put the double pane new window in, bring the tenants back. Well, with vacuum glass, since it's has that thin profile, it fits into almost any single pane glass window in North America. And there's 13 billion square feet, and we're replacing it at less than 1% a year. So we're not solving one of the biggest problems in greenhouse gas emissions in the world is glazing. And now we have a solution that can go into all those old buildings and do fairly cost-effective repairs to dramatically reduce consumption in the largest carbon-producing segment in the world, which is buildings.
Truly amazing. And we're going to come back later and talk a little bit more about retrofits. I want to do a deeper dive on retrofits, but for now I'm going to take you in a
Sure.
slightly different direction. You know,
Let's go.
yeah, I mean, our show is about occupant comfort. It's so we get into air quality, we get into natural light, we get into views, all those sorts of things. So I'm going to go down that road a little bit. So, you know, if you look at the building envelope purely from an energy perspective and ignore the whole occupant comfort and wellness side of it, you know,
Yeah. Yeah.
many would say the glazed area is the weakest link in the envelope, right? And you know, one of the things that has come of that is the 30% window to wall ratio guideline, which I think is a terrible idea. What's your feeling
I'm
on
with you.
okay? So tell me why you're with me.
I think it's a terrible idea. And, um, you know, um, if you move into a cave and you have 36, 40-inch thick walls, and you put a little fire in the cave, you're going to warm that place up. And cavemen did just fine for millions of years. But we're not cavemen. We need windows in order to be human beings, right? And if you have a full big window like this, I think your life is more human than having a window that's 30% window to wall. I don't think anyone's going to argue with you. But when we have an existential issue with global carbon, then you have to go back and forth between those two things. What I believe is this. In California, a Title 24, which is the code requirement for a window, is R2.4, and for a wall it's R20. If you have a piece of vacuum glass that's R20 and 3/8 of an inch, we have the possibility of creating transparent walls that are R20. That is our future. So today, the price point is not conducive to that, but over the next decade, the cost to manufacture vacuum glass is going to drop, and it will open the opportunity to have every wall in a building transparent and have the energy efficiency on that R value, on that conduction and convection. Now, the next problem is glaring too much light, right? And that's where products like yours come into the picture. So I believe that a product like vacuum glass is going to change the way architects design buildings, because you put stucco on the outside of the building or brick or concrete. The ability to clean and keep a glass building viable is a lot better than using something like stucco. So if you have a product that is super energy efficient, looks great, allows as much light as you need or want into the building, I believe that the design world is going to shift towards more glass on the skin. And this story of going from 40 to 30% will be something that people look back at and go, why would they have done that? But that's my thought.
Well, that's the best news I've heard in a while, and I hope you're absolutely right. And I think a lot of people hope you're absolutely right. That's
Yeah.
yeah, that's really exciting. Really exciting. Okay, let's go. Let's take the retrofit road now. I was well. I'm Canadian. It's been double pane up here for a very long time. I was absolutely shocked to see how much single pane glass is still out there.
Well,
You alluded to it a little bit earlier, but tell us a little bit more about how much energy is actually being wasted due to the single pane glass that's out there, and what's the plan to do something about it in the near term and over time.
so in Canada, like you said, it's probably been 40 years, maybe even 50 years that
Yeah,
it's
yeah.
probably 40 years that it's been code. Listen to this. In 2000, that's the first time that I installed double pane glass in California. The
Wow.
code didn't require it, and the price point was such that it wasn't that much of a difference, but no one was going to pay the difference until it was mandated in 2000. So, the state of California has only been installing double pane for 20 years. So that's an indication, and it moves, across the country in the US and then up into Canada, the colder it is, the earlier there was adoption. So there is a lot. And we have, 300 years of history in North America with buildings, and we only have had double pane glass really for 50 years. So there's a lot. So the numbers that I have are about 13 billion square feet, and we're exchanging about 50 million square foot a year, which it's going to take us forever, 60, 70 years to replace that product. It's dramatically going to impact the greenhouse gas emissions in North America. There's the DOE had a report out about 5 years ago that showed over $20 billion a year is lost out the window through single pane. So when we implement this change, it will take a window with R value of 1 with single pane glass, which is the only thing you're not doing is moving the wind in and out of the building. All the heat directly moves right through with the conduction. You could take that old piece of glass out, put it on the rack next to the window, put the piece of vacuum glass in, put a new gasket in, and your product that was R1 now goes to R3 or R4. So it's actually better than a brand new frame with double pane glass. So when you think about that possibility, it becomes an easy retrofit that is a huge impact. You may reduce the building's energy consumption by as much as 30%, depending on if it's a cold weather or a warm weather climate. And when you think about that, if you're going to redo your controls in your HVAC system, right, on a building, which you have to do every 10 to 20 years, well, if you could put in vacuum glass into the old frame, you may be able to reduce your tonnage by as much as 30 or 40%, which means upfront costs that may cover the cost of the single pane retrofit. And then, 30 to 50 years of savings that you then add to that ROI. The solution is a dramatic improvement over what the option that we have today, which is tear it out, throw it away, use more carbon to build new frames and new glass. It's kind of a slam dunk.
Yeah, it's absolutely a slam dunk. Let me ask you about, I'll say, market awareness. How often does the conversation about natural light and views come into play in your work? Like, are your clients generally aware of the importance of the connection to the natural world, or is the focus entirely on energy these days, or is it just cost, or is it some combination thereof? Where are we in terms of that, the view and daylight, and people wanting it?
I think the discussion comes up early in the design, and I think it's almost exclusively assigned to the design architects who have a vision. They can put themselves in that room or that building 5 years in the future. I think getting the story to an owner and getting a contractor to care is a lot more difficult. If you're talking about a a hospital, and you have a lot of care about the health and comfort of the customer, then I think the daylighting and the quality of the light and the amount of light becomes really important. But I think most office buildings, it doesn't. If I've done a lot of work in Silicon Valley. So if you go to those places, they're really thinking about the productivity of their workers. And I know and I know that productivity goes up when you have better quality daylighting, right? And you have more comfort. But it's been a hard story to tell to most developers, right? You need an owner that really understands the value proposition of a healthy building. So I think I think as I'm out doing these single pane retrofits in North America, I think that story is something that we can align with. It's the quality of light, but also the comfort, and the light becomes comfort because glare is super uncomfortable, right? Um, so that comfort, I think, is going to become more important because if you're in Pittsburgh or Toronto or Newfoundland and you stand next to a single pane or even a double pane window, it's cold, right? So with vacuum glass, it's not. You with a building like that in the winter, you lose 12 to 30 inches around the perimeter that people just aren't happy being there, right? With this product, you can be right up next to the window and feel comfortable. And if you've got the right quality of light, it makes just for a better human situation.
Yeah, oh, absolutely. It's one of the selling points of Solera, and the combination would be, oh my God, it would be absolutely brilliant.
Absolutely.
We definitely need to work on that for sure. I listened to your interview with Adrian Lowenstein the other day. It was amazing. I learned a lot of things, and my God, I love to hear two people who are so passionate about the building envelope really dive down into the details, and lots of good conversation about codes. But I want to talk about something specific. I want to talk about economics, and we forget
Okay.
about. It was so refreshing to hear somebody bring economics into the conversation. That's because a lot of it is kind of ignoring economics these days. You talked about how low E glass achieved widespread adoption as a result of the cost reductions that, of course, resulted in a really good ROI. Um, Share your feelings about ROI and code, and maybe give us some examples of, say, the road code should play versus ROI driven technology adoption.
So, I'm a Cold War baby. So the idea of government intervention kind of rubs me the wrong way. So
Mm-hmm.
that being said,
Me
I
too.
do see a place for, I see a place for code. Now, it's obviously been good in the state of California because Title 24 has given us guidelines to get to cost effective, you know, energy efficient solutions. And those codes around the country have done that. What I understand, and using low E as a guide, it was the price that drove adoption. And once adoption gained momentum, then the code bodies were able to mandate it. They didn't mandate ahead of the pricing. And right now, no one's going to mandate vacuum glass, but when the price point gets to a level that the solution has a 10-year ROI, then the code bodies will start mandating it. And if you look at the curve with low E, there's a 14-year adoption curve, right? And it wasn't until 7 or 8 years into the adoption of the product that the code bodies started mandating performances that were only available by, single and double silvers, right? And now they've moved to mandate towards triple silvers and even past that. So that's my thought. Code is good to maintain performance in buildings and comfort, but I don't think it's the driver. I think it usually follows adoption. I've been talking to the California Energy Commission for 6 years about this, and pretty much they told me this: Nick, we want to do it. We're ready to pass the requirements, but you need to show us that there is supply to fill the California market, and the price point is such that it will not hurt the growth of construction in the state of California. And they said that's what the legislators are going to want from us. They're going to want those two things. So, I mean, that's where we are. As soon as there is supply in regional markets and the price point is such that it's can do that 10-year ROI, I think then the code will drive to full 100% adoption over the next 15 years.
That is remarkably insightful for a government agency. I am so impressed.
Well, I think so. I'll go off back to my Cold War guy.
Sure.
Um, if I don't think they care. I think they know that the legislators are beholden to builders and developers and bankers who, as soon as you try to make a code that's going to make their buildings sort of impossible, they will slap the legislators down. And so the legislators are looking for that. They're like, look, this is what we need. We want to do this. We want to put our little badge that we're green, but the people who support us and pay for our campaigns need this. So it's a good balance. It creates the balance that we have in North America and we want to maintain. So
I like that very much. Let's talk about some different technologies. What's your feeling about photovoltaic glass, BIPV? Where do you see that? Does it have a role?
I really made a valiant effort to create some BIPV walls in the mid 2000s, which met with so much interest and zero actual sales. And what I found was people love it, love the idea, would love to have, walls generating electricity. The problem is when you take a glazer and an electrician and you try to put them together, the AEC community doesn't have procedures to do that. And anything that reeks of liability just completely eliminates the possibility of creating change and innovation in the industry. So wiring a window or the electrician's worried about leaks, it makes it very difficult. So I think there is a place, and I think maybe in southern climates where you can get some energy density, but I think the adoption curve for that has not started yet. And I think the problem is integrating the wiring into the window system. So whoever comes up with that solution is really going to help make a step towards BIPV and power density. If you've got just a regular, monocrystalline silica chip, you're sitting at about 22% efficiency when it's at the perfect tilt angle. But you put it in the vertical and you go to 5%, you're losing about 25% of that. So you're getting 3 to 4% actual of the photons that hit the glass become energy. I think the ROI story becomes difficult. Where I think you might have first stages of adoption are photovoltaic products within the window system that actually energize and put DC power into a battery that helps you do the other things that you might want on a window, like electrochromic, like operating the window. So it's kind of localizing the electricity instead of having to do DC wiring and low voltage or high voltage in the photovoltaic case. So that's I don't know if that's a good response, but that's what I think about BIPV.
Oh, that's a great response. So in the situation, like a skyscraper, even just an ordinary tall building, you've got a very low roof area relative to total occupied area in the building. How do you get to net zero without having that the ability to generate some electricity in the building?
Well, I think the first thing is get the energy efficiency of the building down and the embodied carbon down
Yes.
as much as you can, right? That's the first step. And that whole consumption side we have not been there for the last 15 years. It's like we really did a great job in North America and Europe of reducing our carbon footprint. And what we did is instead of burning coal, that's freaking horrible, we went to natural gas, which is still burning carbon, but it's just dramatically more energy efficient and less carbon intensive. So we did a good job, but we started generating, carbon-free electricity with solar and wind. But the consumption place is where you and I and the glass industry and the AEC can make a huge impact, right? If we can reduce the consumption. So you want a high rise that's zero energy, get the consumption down to 70% below. And then, maybe there's possibilities for sunscreens and things like that where you get the perfect angle and you don't need transparency to give you better quality light. So maybe that's on the south elevations of a building. In the west, you do sunscreens that don't have to be transparent, or you do a transparent photovoltaic with a sunscreen, and now maybe you're getting some of the power density. So those are two ideas that I would throw out there. And then you can have regional solar that feeds the city. In California, that's easy. You fly from here through Nevada. There are thousands of acres of solar farms producing energy and pushing it back into the grid. So, I think, from my knowledge, those are more the better solution. Or, so I hope that answers your question.
Very much so. Yeah, that was a great answer. I have to tell you a little tidbit of information. Here in Nova Scotia, most of our electricity is generated by burning coal. Still, we charge our Teslas by, by burning coal to generate the electricity. It's
wow, yeah,
it's bizarre. Yeah, I mean, we have a relatively low population density here, but still, we burn coal. Coal we bring from South America too to generate.
Wow.
Oh, yeah.
Yeah, I would for some reason think that you guys had hydro up there, because I know Montreal and Quebec and in that area there's a lot of hydro. So I would have thought Nova Scotia would have some as well.
We don't have the big rivers here. There's nowhere in Nova Scotia where you're more than, I think it's 50 miles from the ocean. So you don't get the really long, high volume rivers. So hydros, we've got some tidal. We do have some tidal, and wind is growing as well. But the core is still coal, which is hopefully we'll see some change in the near future.
Yeah.
Let's go back to electrochromic. You mentioned electrochromic just a few minutes ago, and I'm going to go back to the conversation you had with Adrian recently. You actually referred to electrochromic as a novelty product, which I do agree with. But I want to hear you explain why you made that statement.
Well, I've dealt with art glass my whole career, and there's a place for a $50 per square foot piece of glass if someone really wants that, and it becomes, I think, a novelty. My experience with electrochromic glass is the actual sputter coat process that is being used today has a lot of difficulties with quality control. So getting a piece of low E glass with, vacuum deposition to have 50% light transmittance. What you don't know is there are tiny specks and holes in that lighted glass, but since you have 50 to 70% light transmittance, you don't see those. When you take that down to 4%, 1%, any tiny hole becomes like a beacon of light through. And the process was not designed to do that. And so the process that the large funded companies are using today will not get to a cost of goods sold such that it's competitive and inspiring to actually get the product. That's my belief. And then that same problem of wiring that you have with photovoltaic moves into the value stream in a way that makes owners, architects, and the actual subcontractors worried about liability, because you're crossing over trades in a way that we haven't found a comfortable, effective way to do yet. So I installed some of the first electrochromic in North America in the late 2000s for Kaiser Hospital, for the Sacramento Municipal Utility District. It's great. I love the product, and it's cool to see it change. But I have never been able to get it to a cost-effective solution. So that's my thought with EC.
Right. Excellent. Now we're going to talk about framing. I get to have a glass guy
Okay.
on to talk about framing. You lose a lot of energy through the frame, rather than just, you don't get the center of glass R value for the overall system. Do you have
Right.
any ideas on what can be done to improve the energy performance of the framing system?
Yeah, so my personal experience was that is I was contacted about 6 years ago by a large global manufacturer about vacuum glass, and they said, Nick, we're thinking about bringing this product to market. And I'm like, well, I've been asking you for a decade, guys. First time I saw it was in a science and technology center, and I walked by a freezer. I could tell there were popsicles in it. It had a glass door, and I'm like, and you could tell that they had jury rigged this glass door on a freezer. I'm like, what the hell is that? And they're like, touch it. So I touched the piece of glass with popsicles on the other side. It wasn't even cold. And I'm like, what the hell is that? And they're like, well, that's vacuum glass. And I'm like, I want to sell that. So a decade later, they came to me and said, we're ready to do this. And I said, okay, well, I believe you, but send me a piece of glass. So they sent me a piece of glass that fit the NFRC, two pieces of glass that fit the NFRC test. I put that in my thermally broken unitized curtain wall that goes on in the airport at LAX and Sacramento Kings Arena and Google buildings and Kaiser hospitals. I put the vacuum glass into that, did the NFRC test, and the R15 vacuum glass tested at R6. And my system, the best I'd ever squeezed out of it was an R3. And I'm like, well, this works. It's amazing. It's 100% improvement. Let's go. But I also thought 6 years ago, well, shit, I'm losing 66% of this amazing product's performance. It's like taking a brand new Tesla motor and putting it in a 72 Pinto, right? So every frame in North America and Europe today, well, maybe the Germans have a 77, Volkswagen Golf, right? So, but the systems do not meet the performance that we can get now. So, I think building framing systems that are energy efficient are the next stage for new construction. So, if you can double performance with a 20% increase in the cost of a system, then everyone's going to go there, right? Because if you take $100 unitized curtain wall, let's just square it out to $100, and you have glass that's about $15 for double pane, triple silver, low E, right? So it's 15%. You double the price of the glass, which vacuum glass is plus or minus $30 per square foot, right? You've only got about a 20% increase in the cost of the unitized curtain wall system. So that can be met pretty rapidly with reduction of HVAC in a new building, so you downgrade your HVAC and the energy performance, you've got a fast return. Now what's going to happen is getting double performance is going to sell the product, but competition is going to drive to a 400% improvement. And that will happen rapidly. And that will be one of the things upstream from the glass. So we got glass that's super performing. What's going to drive the adoption are the super performing frames. So that is, let's look at what the Germans do with their thermal breaks. Schuko here in North America has trouble selling that product because, frankly, the glass sucks, right? Now we have super performing glass. We can go to these super performing frames and get high performance. So I think having better and more thermal breaks, I think is a key, which that's the solution that we've been working towards. And then using less conductive materials for our framing system is where we're going to go next. And that's, like Rovex or a pultruded
glass curtain,
fiber. Fiberglass.
Mm-hmm.
That's where we're going to see some real innovation, because now we have a baseline product that will get us to an R20 wall. Now the race is to build the framing systems that will accommodate it. And I really like that analogy, taking that Tesla motor and putting it in a 72 Ford Pinto. At least it's not going to blow up because there's no gas tank in the back. But, the frames are now behind the glass technology. So.
Yeah, the analogy I always think of is playing whack-a-mole, and right now the framing the
Yeah.
framing is the little mole that's got its head poked out right now, and nobody wants to be the mole with their head poked out. So as
Right.
the glass technology improves, that head pokes out even farther. And now it's time for the industry to whack it, you give it a whack and fix that problem.
Absolutely. And that adoption is not rapid because you can't just go, hey, I've got a super performing frame. You need to design dies, engineer that, cut the dies, recut the dies because of issues.
Mm-hmm.
It's, look at a company like Conair. They probably have or YKK or Wausau. They have 1,000 systems. Each system has 100 to 200 parts. It's $1 million to bring one new product to fruition. So they are going to have to start slowly, find where the adoption is, then incorporate those new suites into their existing catalog. So that's going to take a while, right? But I think that's a 15 years. We'll be there. We'll have every glass specified in North America, and Europe will be vacuum glass within 15 years. That's my prediction.
Right. Well, I'll in 15 years, I'll come to California. We'll have a glass of wine somewhere on the coast, and we'll see if we'll discuss if your prediction is true.
So I'll pop down from Nevada. So because I'm a Nevadan now.
Oh, that's right. That's right. Or you can come up to Nova Scotia. It'll be nice and warm.
All right.
Then.
I'll do it in the spring. I'll do it in the spring or summer.
Come in the summer for sure. Yeah, we have terrible springs
All right.
here. Okay. Interestingly enough, we are having one of the most difficult winters we've had in a very long time. Winters have started to almost disappear here, and in the last 2 weeks, we've had close to 7 feet of snow in total.
Wow.
Yeah, state of emergency, the whole 9 yards. It's been
so a little warmer, but so more water in the atmosphere, so you're getting more snow. Is that it?
I don't know. We haven't had this much snow in a really, really long time. Like I had to look for my shovel when this came. Let's just put it that way. I had to do a little work on my snowblower to start it up again.
To get it
yeah,
going.
It's been sitting idle for so long. I didn't start it up last year. I didn't start it up the year before.
And that's nice, though.
It very much is. But this year, holy cow! Anyway, let's ask the $1 million question. The question I ask of every single guest, and you can answer this from whatever perspective you'd like. What makes a great building?
I think a building that withstands the test of time. And I think that there's like a couple of different elements there. I think a building that obviously that looks good. When you look at the Parthenon and those buildings in ancient Greece, you know, or if you go to one of the cities in North America or Europe, you look at the exterior of those buildings and how they fit into the community and the environment is super important. And then I think when you're talking about that exterior or that facade or, you know, what people see from the outside, it's really important that the ability to maintain that over decades is whether that's the visual and aesthetics or the, you know, efficiency and just cleanliness of the building. So I think glass leans well into that. If you like the modern look, and glass is easy to clean versus, you know, a lot of other products. And then I think the second, and that's the one that people think about. When you think of Paris, you think of the beautiful buildings. You don't necessarily think of the comfort in the buildings. But if you go into those buildings, they have big, thick walls, you know, and they'll have 2 to 3 window systems because that's what you needed to create comfort. So I think you have to almost immediately go from what looks good on the outside and what is the community facing side, of the building, to how it feels to the individuals who live in those buildings and work in them. So the second is comfort, and that, like we talked about, we started this off, is daylighting becomes super important, and then the heat transfer through those windows becomes very important. So, yeah, I think a building that will last 100 years, be comfortable and efficient and look good. I mean, I think that's what we're all striving for if we're looking to build great buildings, right?
I love it. Okay, before we sign off, Nick, is there anything that you'd like to
Okay.
promote or any news that you'd like to share that we haven't talked about today?
No, I talked a little bit about single pane retrofit, but I mean, that's what I'd like to end on. I believe that one of I know that buildings are responsible for 40% of global carbon, right? About 10% is the embodied carbon in the construction, and about 30% is the um, energy usage, over the duration of the life of the building. And I think we have a responsibility in our industry to make better walls. And I think now we have the possibility. So the single pane retrofit is a way to go out and immediately affect the embodied carbon for the retrofit, because if you need to build a new frame and do all of that, you're increasing the carbon dramatically, and just the energy efficiency of that building, and that 30% of global carbon that goes out the window in buildings is really something that we can attack now and dramatically help reduce global carbon. And we talked a lot about carbon, but when I think about the other effect of this, if you have a building, say you're an average income person in the United States, it's about $50,000 per year is your average income. So when you look at your probably apartment payment, right, and the car to get you to work, those are your two big bills. The third bill is your energy bill in colder climates, or the food for your children. If we can reduce that energy bill, we can dramatically affect millions and millions of people who need this the most. So I really feel like this single pane retrofit is going to increase comfort and the ability to live in a much more healthy way in North America and Europe as these products get adopted. So I'm dedicating the rest of my career to build awareness that this product creates a possibility to dramatically reduce the cost of living in a building, which then also reduces the amount of carbon. So I can end it on that.
That's wonderful. Nick, thank you so much. It's been a pleasure talking with you, and I definitely want to chat with you more in the future. You take
Yeah,
care.
anytime, Joe. I'm really happy to be here.
Of
So
course.
thank you.
Thank you again, and take care, Nick. All the best.